Welcome to qnawire.
So here for part A, we know that the velocity is found by integrating the acceleration with respect to time. And so we can use the substitution, and so we can say that the initial value of u, so u initial is going to be g minus k v initial, and this is going to equal g. So we can say that a, the acceleration, is going to be equal to the derivative of the velocity with respect to time. Therefore, dv will equal a dt, and we can say dv equals g minus kv times dt. And so we can say that dv over g minus kv will equal dt, and then we can make the substitution where u equals g minus kv. And so we have that dv equals negative du divided by k. Let's get a new workbook here. We have dv divided by g minus kv. This is equaling, again, dt. And we can say negative du over k times 1 over u is going to equal dt. And we can say, of course, du over u is going to equal negative k dt. And now we finally integrate. So integrate this from g to u, and then integrate this from, of course, 0 to t. This is going to equal negative k times 0 to t of dt. And we finally have natural log of u evaluated at g and at u is going to equal negative kt. Let's get a new workbook. So u is, so we can say the natural log of u over g is going to equal negative kt. So we can say that u is going to be equal to g times e to the negative kt. Remember, e is simply just the value 2.73 approximately. So g to the e to the negative kt power, and this is going to equal g minus kv. Basically, we're substituting back in for u this right here. So this is when we substitute back in for u and then solve for v. So isolate v at this point. So v is going to equal g over k times 1 minus e to the negative kt power. So this would be your answer for part A. For part B now, we want to find the terminal velocity. So the velocity terminal would be equal to the limit, as t approaches infinity of g over k to the 1 minus e to the negative kt power. And this is simply going to, this is an exponential decay, of course, so the terminal velocity would simply be equal to g divided by k. We also, just to note that if acceleration was 0, which again happens at terminal velocity, then a is going to equal g minus kv, and this is going to equal 0, and then we can simply solve for v. So v is going to equal g over k. So if we say that the acceleration is 0 at terminal velocity, then we can just set up an equation and solve for v. However, this way is a lot better because we can. This gives you more information. It gives you more information in the sense that velocity, the definition for the terminal velocity, is the limit as time approaches infinity. So again, the terminal velocity will equal g over k. This is your answer for part B. That is the end of the solution. Thank you for watching.